All right, so we have a question here that we've been asked to simplify the square root of 1 minus sine theta divided by 1 plus sine theta. Now, this might look very trickish, but it is quite simple, very simple. So what we are going to be doing is there are some trigonometry function that we should already know by now. Trigonometry functions like sine squared theta plus cos squared theta equals to 1. We are going to see the real application here. So the first thing I want to do here is that if you look at this question, the denominator is carrying a 1 plus sine theta. So the first thing I want to do first is that the 1 minus sine theta divided by the 1 plus sine theta, I want to multiply both the numerator and denominator by the conjugate of that denominator, which is 1 minus sine theta. So don't forget, if I cancel them out, I'm still going to have the question back. So it's not as if I've done anything very different. I'm just trying to manipulate the question, simplify it further so that it is much easier for me to do. Now, by the time I have this multiplication, you notice that the numerator, we have two of them. We have 1 minus sine theta and 1 minus sine theta. So that means it is carrying a square. It is replicated in two places. So we put a square. Now for the denominator as well, we have 1 plus sine theta and 1 minus sine theta. If you remember from difference of two squares, now, the principle of difference of two squares is already established in the fact that if we have a difference and you have two squares connecting them, that's something like x squared minus y squared. It is always going to be equals to x plus y and x minus y. Now, in this context now, the x is being used as 1 and the y is being used as sine theta. So we have that 1 square minus sine squared theta is going to give 1 plus sine theta and 1 minus sine theta. So we've manipulated that 1 square minus sine squared theta using difference of two squares. So that's what has been established on the board. And now from here now, we can now begin to simplify further and we can go back to the original equation that we started solving. From that third step, we have 1 minus sine squared theta all squared over 1 minus sine theta all squared as well. So from here now, you can note that from this denominator, from what I established earlier, that sine squared theta plus cos squared theta equals 1. If I decide to make cos squared theta the subject of the formula, it means sine squared theta is going to go to the other side and it becomes 1 minus sine squared theta. Now, having established that, we can now substitute that into the denominator, saying that cos squared theta is equals to 1 minus sine squared theta, and we have the new expression here. Now, from here now, we can also see that if I write cos squared theta, it is the same thing as cos theta all squared. So that squared is capturing both cos and theta. So I rewrite it as cos theta all squared. Now you will now notice something unique, that the numerator and denominator are both carrying a square. Now, because they are both carrying a square, we can now say 1 minus sine theta and cos theta all squared. So having established that they are both carrying a square, and we know that square always cancels square root. So that means we are left with 1 minus sine theta over cos theta. We can go ahead to break this further and say this is the same as 1 over cos theta minus sine theta over cos theta. And we also have from trigonometry identity that 1 over cos theta is given as sec theta. Don't forget those ratios, that 1 over cos theta is sec theta. So we substitute that, and we also have that sine theta over cos theta is equals to tan theta. And from there, we can now establish that 1 over cos theta minus sine theta over cos theta is now going to be equals to sec theta minus tan theta. And that gives the final simplification. Thank you. Do like, share, and subscribe. God bless you.